Welcome to my channel. If you like my videos, then kindly subscribe, like and watch. Thank you.
Okay, sample problem 2.1. In this problem it is given that this is a bar and that is linked with bar A, B and C, D. So the rigid bar, the rigid bar means the bar does not undergo to the deformation under the load because it is rigid. So the rigid bar BDE, so this is BD, this bar is a rigid bar, is supported by two link AB and CD. So there are two link that is attached with this bar BDE. So link AB is made up of aluminum, that its modulus of elasticity is given, that is 70 gigapascal, and cross-sectional area of 500 square millimeter. So area and modulus of elasticity is given for AB. Similarly for link CD, modulus of elasticity as well as cross-sectional area is given, and the load of 30 kilonewton is applied at this end. So you are asked to find out the deflection of A of B. The B part is deflection of D and deflection of C. So you have to find the deflection at this B in link AB. So that is deflection of B. Deflection of B is equal to deflection in AB link. Similarly, deflection in D is equal to deflection in CD. And deflection at this end, which is deflection of E. So you have to find this. For that, we must know about the forces that are available in these links, because delta B will be equal to PAB into L length of AB divided by area of AB into E of AB. So you can see that you have been given EAB, AAB length is also given over here, but you do not have force. So how you will find the force? So definitely for that you have to draw the free body diagram in order to find the unknown forces. So let's move toward that. So if you draw free body diagram of this rigid bar BDE, so it will be like that, and you can see that at point E there will be a load, at point D there is a force, and at point B there is also a reaction force, and the distance is same as given above. So what do you think if this load is applied? So definitely this will tend to stretch DE, and again this force will be upward. But this is the force that will be in this bodies. Clear? And if you want to show them on this rigid bar, so it will be like this. This will tend to exert on this body, and similarly this will also tend toward it. So if you assume any direction, but when you do calculations you will get the value, and based on that value you can see that whether it is tensile or compressive. So let's start with this. So now here it is given that that is 30 at point B, point D. The reaction force is FD, because we have removed the link CD. So this reaction force is represented as FCD. Similarly, at point B, the reaction force is FAB. Now, how can we find the unknown forces? So we know the equilibrium condition that sum of all the forces along x direction is equal to 0, or sum of all forces along y direction is equal to 0, or we can use sum of all the moment at any chosen point that is taken as 0. So if there is no horizontal force, so definitely we cannot apply this equation. So we will start with sum of all the forces along y direction is equal to 0. So we can see that this is minus 30 plus FCD plus FAB is equal, their sum should be equal to 0. So we have one equation like this. Again, we can also use the moment equation. So sum of all the moment we are taking at point B. So if you are taking the moment about point B, so one force that is 30 kilonewton that will produce movement in clockwise direction. Clear? So in clockwise direction, so this moment will be 30 into this distance, this whole distance, and this is 0.6, and it is clockwise direction, so that is negative, so minus 30 kilonewton into 0.6. Now the second force that is creating movement about point B is FCD. So FCD into perpendicular distance is 0.2. So it is producing counterclockwise, so that will be positive. So plus FCD into 0.2, so that will be equal to 0. And when you simplify it, you will get FCD will be equal to 90 kilonewton. So plus sign means that you have assumed direction in this upward, that is correct one. Clear? Now, if you put this FCD over here, it will be also okay. So if you put the value over here and then you move it, so you will get FAB is equal to minus 30. Wait a minute. I have a call from chairman. You can see that you can use this equation, and if you do not use this equation, clear, so you will, okay, let use this equation as well. So FAB will be equal to plus 30, it will go toward this, and FCD is 90 and it will go there, and that will be minus 90, so it will be minus 60 kilonewtons. So now you have FAB as well as FCD. One more thing, if you do not want to use this equation, so second method is that if you want to take the moment about D, so you can also use that. So in that case, one moment that is produced by this 30 into 0.4, that will be clockwise, and the second one is moment about point D is FAB into perpendicular distance, and it is also in clockwise direction, so both will be negative, and by using this equation you can also find FAB, which is negative. So it means that FAB is in compression. So we have assumed here the force upward, so it means that our desired or our given or assumption that we have taken this force upward is wrong, so it should be toward downward. Clear?
Yes, sir.
Okay, then we will move to find the strain in each bar. So you can see here that this was the link AB, which was over here. So now the force that is, we assume that this was upward and was, but actually the reaction force on this bar is toward downward, and similarly the same force on link will be in opposite direction, because here you are showing the reaction forces, but the actual force acting on this link AB is upward. Clear? So this is 60 kilonewton. 60 kilonewton. Okay, and there is also a reaction force at the top as well here. So it will, this link AB will be in compression. Clear? So we know that deflection in AB or deformation in link AB is equal to PL divided by AE. So you know here the force is compressive, so P in this area is minus 60, which you have calculated earlier. Clear? So this is minus 60 into 10 raised to power 3. Length is given as length of link was given above, that is 0.3, and area is also given for AB, which is 500. So all values are present, are available. Clear? So you have to put the value and you will find the deflection in or deformation in link AB, which is equal to B, and that is minus. So it means that there will be contraction in AB. Now displacement at point D. So at point D we will draw the link of CD. So as this force is, reaction force is upward, so it means the force acting on link CD is downward. So now this force is creating tensile stress and tensile force. Now due to tensile force there will be elongation, and that elongation in link CD can be found by using this formula, PL over AE. P is the load, that is here tensile load 90. L is the length of this link, which is 0.4, that is given. Area was also given 600 square millimeter, and G for this material is also given. So you have calculated the deflection or deformation at point D. So in this problem you have up till now calculated the part A, which is deflection at B, part B deflection at D. Now we will find the deflection at this point E. So for that we have to draw a simple line or diagram like that. So this was the initial problem. You can see that this BE is total length of this rigid bar, and this is point B. Now you have noticed in previous solution of deflection at link AB, so you found that the deflection there was a negative one. So you means that there is compression, upward compression, and that compression was 0.514. Similarly at point D you have noticed that there is a deflection, and that is positive, which is 0.3. Again, if you want to find deflection over point D, so that will be deflection at point E, delta E. Now you can, if you draw this figure, you will find that this, if you join this point with this, so you will find that there is a point at which there will be no deflection. But we do not know where the position of this point lies. So initially it is given 0.2 meter or equal to 200 millimeter. So let this point H is at a distance of X from D. So this distance will be equal to 200 minus X. Clear? So you have a height BB dash, DD dash and DE dash. BB dash is the deflection at point B, which is compressive. DD dash is deflection, or deflection means elongation. So elongation at point D, which is positive, means there is elongation which is 0.3, and you do not know the elongation or deflection in point E. So for that, if you see this figure, so we have three equal triangles. Clear? So this triangle B, B dash, H, we have another triangle H, D, D dash, and similar triangle, not equal, similar triangle. So we have another triangle H, E, E dash. By similar triangle, we means that if two triangles are similar, then the ratio between their corresponding length will be same. So what does it mean? It means, for example, if you are going to take triangle B, B dash, H, that is similar to triangle H, D, D dash. So it means that if you are taking the ratio of B, B dash, B, B dash with respect to D, D dash, it will be same for BH over HD. Clear? Is that clear to you?
Yes, sir.
Okay. So BB dash is what? BB dash is 0.514 and DD dash is 0.30. BH is actually 200 minus X, and HD is equal to X. Clear? So you have this equation. If you solve it, you have to multiply this X over here, and then you further solve it, so you will get X is equal to 73.3 millimeter. It means that from point D, when we move till 73.7 millimeter, so we will get a point where deflection will be 0. Now the same methodology will be applied between these two triangles, H E E dash and H D D dash. So we will take the ratio between their corresponding sides. So E E dash ratio is taken with D D dash. So E E dash over D D dash is equal to E H or H E over H D. Clear? Now E E dash is generally represented as delta E, and you know that D D dash is 0.3. HE is total length, which is what? Which is the length of X plus this length 0.4. Now it is in meter and here it is 400, that is in millimeter. So 400 plus this distance X, which is 73.3. So that is HE. Divide by HD. HD is 73.3. So when you calculate it, you will get the deflection at point E. So by this you have calculated the deflection or deformation at point B, D and E. So this was all about sample problem 2.1. Any question? If you have any question, you can ask.
सर क्वेश्चन में जो हमें ये बार दिया गया है सर, ये तो इसने कहा कि रिजिड है.
हाँ रिजिड है. तो इस अच्छा इसमें इस बार में एट पॉइंट ई वो डिफॉर्मेशन इसमें नहीं आ रही, मींस ये डिफ्लेक्शन है जो इसमें, मतलब ये इनिशियल पोजीशन से नीचे, तो ये डिफॉर्मेशन नहीं है, ये एक किस्म का डिफ्लेक्शन है. जबकि ये सी डी और ए डी हमने उस फार्मूला से यूज किया, पी एल डिवाइड बाई ए ई. ठीक है ना? सो ये डिफॉर्मेशन है और ये डिफ्लेक्शन है. समझ आई?
सही सर, सही.
क्लियर?
यस.
एनी अदर क्वेश्चन? Okay, now we will move towards static indeterminacy. So what do you mean by static indeterminacy? So whenever you have been given a problems and you have, for example, if you have any problem and there are four unknowns, and you have by using equation of equilibriums, you have three equations: sum of all forces along x, sum of all forces along y is equal to 0, and sum of all moments is equal to 0. Now in this case you have four forces or four unknowns, but you have three equations. So you cannot find the four unknown by using three equations. ये तो clear है ना आपको? So we cannot solve this problem by using these available three equations. So such type of problems or such type of condition comes under the category of static indeterminacy. So structure for which internal forces and reaction cannot be determined from statics alone are said to be statically indeterminate. Clear?
Yes sir.
Okay, it will be clear to you further when we move ahead. So yeah, so this is the example. You can see that this is a member having cross-sectional area A 400 square millimeter and length is 300 mm. Clear? And this is, there is another member of area 250 millimeter square and there is a load acting at point D and K. So if this, in this condition, if you take this condition, so there will be a reaction force from the bottom that is represented as RB, and if you remove this reaction at point A, so there will be reaction at RA. So if you apply the equation these by using three equation, so as sum of all forces along x direction is equal to 0 cannot be applied on this because there is no horizontal force in this condition. Sum of all the force along y direction can be applied. So in that equation we will get RA minus RA plus RB minus D minus K is equal to 0. So there will be two unknown. But we cannot also use moment equation in this problem, because if you want to take the moment at point B, K or D or any, so all the forces are passing through the same point, so there will be no moment. See? So we can only use one equation. Sum of all forces along y direction is equal to 0. Clear? Now if you use this equation, so in that equation you will have two unknowns and the equation is 1. So you cannot solve this problem by using equilibrium condition. So this type of problem is known as this is known as this phenomena, or this is known as statics indeterminacy. So we will solve it by using a method that will be explained now. Clear? So if you want to solve that type of problems you may encounter, so for that you have to take one of the reaction force as redundant force. Now redundant forces are those forces if we want to neglect or remove it, so it will no effect on the statics of this body. How? अगर आप ये रिएक्शन फोर्स इधर से हटा दे तो ये फोर्स इस पे लग रही है, ठीक है ना, तो ये इस बॉडी को मूव नहीं कर पाएंगी क्योंकि इट इज आल्सो सपोर्टेड एट ए. सिमिलरली अगर आप ये सपोर्ट ऊपर से हटा दें और ये पड़ी हो यहाँ पे, तो इस कंडीशन में तब भी ये ऑब्जेक्ट या ये बॉडी मूव नहीं करेगी. क्लियर? सो वी विल यूज दिस टेक्निक टू फाइंड आउट द सॉल्यूशन. तो अगर आप देखें तो ये पहली जो इसको मेथड अगेन इसको देखें, इस पहली वाली को, इसको जो मैंने टिक लगाई है. सो इफ यू लुक एट दिस इज द सेम थिंग and the reaction is given below. Clear? So there is no deflection or no deformation. Now this is statically indeterminate. So what is the solution? So first we will neglect this redundant force or reaction force at point B. So if you neglect this force, so definitely you see that due to these forces there will be elongation in this member, and this elongation will be, let's say this was its original length, so there will be elongation that is delta L. Clear? Why? Because we have neglected this reaction force at point B. Now this deflection can be found by using the technique that we discussed earlier in our previous lectures. So you have the equation sigma is equal to PL over AE, but it is not easier as you think. So here you will have to take one section over here, then there is a sudden load change, so another section over here, then there is another area change, so you have to take one cross section here and here. So totally four sections you have to find the deflection and then you have to add that. ठीक है ना, आगे सॉल्व है उसको देखते हैं, बट आपको सिर्फ समझाना है. Once you get the deflection, that will be elongation due to these stresses. Plus, if you have to neglect these forces, so it will be like that, these reaction forces and these upper forces. So in this case, we have neglect these forces, so we say that this is compression, and due to this compressive forces, it will compress to this amount delta R due to compression. This is reducing. But if you look at the problem, initially it is given that total deflection or total deformation is equal to 0. So we have changed our problem from this to combination of two combinations, in which one elongation is increasing and in other the same elongation is now as the load is in compressive, so same decrease in length is seen. Now as total elongation must be equal to 0, so sigma L plus sigma R should be equal to 0. Now this is the second equation with the help of which we can find the two unknown forces. How? So let's see this example. So again, this is the same thing. I will go toward this thing. So first you have to take from free end to the fixed end, we will move. So you have to take the first area, first section over here. Now at this point, there is a load change. So here you have to take in second area, or at this point you can take. Now there is a change in area over here. So that will be third section, and there will be a change in load, fourth section. So we will see if you cut this at point 1. Let's see, this is the 1. If you cut at this point 1, so there will be no load. So here in this condition, P1 will be equal to 0. At point 2, there is a load. Clear? That is how much? 600. So P2 is equal to 600. And at point 3, the same load. If you cut it and draw the reaction forces, so P2 and P3 are same. That is 600 kilonewton. Now at point 4, so if you cut it at point 4, so there definitely all the forces, this force, this is 600, this is 300, 900. So reaction force will be also 900. So P4 is 900. Again, you have the diameter, you have the area that is given of this section. So area A1 will be same. This A is equal to A1 and A2. And this area is same for A3 and A4. Any confusion? Is there any confusion?
No, sir.
So A1 and A2 is equal to 400 into 10 raised to power minus 6 square meter, and A3 and 4 have same value. Now L1 is, this is given, this was, let's say, the length of first section, this is the length of second, third and fourth. So all are equal in this case, that is 150 millimeter, and if you convert it, it will be 0.150 meter. Now change in length can be found by using this equation, summation of Pi Li over Ai into Ei, and when you put all the values P1, P2 and all this value, and you solve that, so you will get this change in length is equal to 1.125 into 10 raised to power 9 divided by E. Clear?
Yes, sir.
Now the material is same. There is nothing is mentioned that this is different material. So we consider that E is same. Clear? Now this is sigma L. Also, this is elongation. Also, we note that if you consider that, neglect these forces and choose the second scenario in which reaction forces are available. So you can see now here, if you take one section, so that will be here, the force will be equal to RB. And if you take the second section, so load will be same, P1 and P2 will be same, equal to minus RB. Clear? Because the forces will be compressive. And you have A1 and A2 as well as L1 and L2 as well. And so again you use the equation change in length. So you will, when you solve it, so sigma R will comes out to be 1.95 into 10 raised to power 3 into RB divided by E. Now it is given that total strain is equal to 0. So you have to, the sum of these two must be equal to 0. So when these two are added, so the value of sigma L is inserted and R is inserted, and that should be equal to 0. So now there is one unknown, RB. So if you put the value of RB and you have E, so you can calculate the reaction force at point B, 577, sorry. Clear? Now you have the equation which I have talked about earlier, sum of all forces along y direction. So RA minus 300 minus 600 plus 577 is equal to 0, and so you can calculate the reaction force at RA. So initially we have seen that this problem is statically indeterminate. Clear? But
Yes, sir.
for handling such type of problem, we have divided this into two scenarios. One with removing the redundant reaction, and other in which the forces are neglected. And then we solved that, and we calculated the two equation, change in length of increase in length or deformation, and decrease in length, and their sum must be equal to 0. And then we solve this problem to understand this all the phenomena that is mentioned above. So we calculated RA and RB value. So this is how static indeterminate problems can be solved. I think it is clear. Clear?
Yes, sir.
Okay, now we will move toward another topic, that is thermal stresses. Now, thermal stresses, from its name, it is mentioned that these are the stresses which are due to the heat or change in temperature. So, these are the stresses that are generated in the body due to the change in temperature. Now, this change in temperature may be increase in temperature or decrease in temperature. So you know that if there is an increase in temperature, so there will be elongation in the length of the body, and if there is decrease in temperature, so it will shrink. There will be a contraction in this body. So we have a bar EB that is fixed in between 2 points A and B. The length of this bar is L. So this beam is fixed. Now, due to change in temperature, it will tend to elongate. Clear? But we have restricted it from elongation. We have support over here. So in this scenario, change in length will be equal to 0. Because why change in length is equal to 0? Because we have restricted them. We have restrained them. So a temperature change result in change in length or thermal strain. Whenever there is a thermal temperature difference, so there will be a change in length. That change in length is known as thermal strain. Usually that change in length is thermal strain. Clear? That is due to heat. But in that case, there is no restriction. For example, if this is the same bar and one end is fixed and other is not fixed, and it is subjected to thermal loads, due to temperature change, it will elongate. So initially it was of length L. Now there is elongation, that is T. Why? Because there is no restriction at this end, so it will tend to elongate. So in that cases, there will be no thermal stresses in the body. But if you restrain them or if you restrict them at both the ends, so there will be no elongation or no deformation in that. So in that case, there will be stresses generated in this body, and these stresses are known as thermal stresses. Clear? So again, if you look into this problem, this beam is attached or supported at both the ends. So there will be, if we remove this reaction, so there will be a reaction RA, and at this point there will be a reaction RB. So you have two unknowns, and you can apply this equation only. Sum of all forces along x direction is equal to 0. So by using this equation, you cannot find both of the unknowns because there is one equation. So this problem is statically indeterminate. So how we will solve this problem? So let's start that. So assume that if this beam is fixed at one end, but at the second end it is not supported. So due to heat thermal change due to temperature change, it will tend to elongate and it will come to a new position, that is, or the change in length is delta t. Now you have studied this in your metric or FEC that due to change in temperature, the deflection or deformation that is equal to delta t is equal to alpha delta t into L. Clear? So this alpha is known as coefficient of thermal expansion, L is original length and change in temperature. ये याद है आपको?
Yes sir, 9 में था.
हाँ ठीक है. So this elongation due to thermal heating is this much, and we can, if you have alpha, you have change in temperature difference and original length, so you can find the elongation. So one elongation can be found by using this. Now in first scenario we have considered that there is no reaction. We have removed this redundant reaction at this point, which is RB, and consider that there is no reaction at this. So due to temperature difference, it elongates. But now we assume that there is a reaction force due to this support B. So we represent this reaction force as compressive force. Clear? So now due to this compressive force, we say that due to this compressive force there will be a contraction in the length. And how much will be the contraction? This will be the same as that elongation, but it will be in opposite direction. So again we say that sum of all deflection, if you use this problem initially, so here total deflection is 0. Now if this total deflection is 0, it means that change in length due to thermal plus change in length due to the redundant or reaction force, that must be equal to 0. Clear? आपके पास ये value है sigma t, which is given over here, and due to these reaction forces the deflection can be found by using PL over AE. Now P is this reaction force, L is total length, A is the area, E is the modulus of elasticity. So again we will use the same this equation. Total deflection is equal to 0, so that is equal to delta T plus delta P is equal to 0. Delta T is alpha delta T into L is delta T की जगह हमने ये put कर दिया, we have put this, and delta P की जगह हमने PL over A put किया. And when you solve that, so you do not have actually P, which is reaction force at B. So you will get P is equal to minus AE alpha into delta T. So you can find this reaction force. जब आपके पास एक reaction force आ गई, आप उसी equation में put करें sum of all forces along x direction. So you can also find this reaction force at A. Now one more thing is that if you divide this A on both sides, so that will be P by A, and it will be, this A will be cancelled, so P by A is equal to sigma, and this sigma is equal to minus E alpha into delta T. Now this is known as thermal stress, because due to this reaction or strain, there is no elongation in this rod, but if no elongation is there, so definitely thermal stresses will be generated in this body, and the value of this thermal stresses can be found by using equation sigma is equal to minus E alpha into delta T, and this is known as thermal stresses. Clear?
Yes sir.
Any question? Okay, now we will move. जी किसी का कोई question है?
No sir.
Okay, we will move toward Poisson ratio. So उसके लिए आपको थोड़ी चीजें मैं समझानी पड़ेंगी, और उसके बाद जो है फिर मैं Poisson ratio की तरफ आता हूँ. So for that मैं आपको, मुझे थोड़ी space चाहिए. So I will start from that. Okay. So let's choose any. Okay, from this point, इससे ऊपर में या कोई भी कह देते. Okay. So, for example, if you have a bar, that for example, this is the bar. Clear? Having original length L naught, yeah, L, and that is subjected to normal load P. Clear? So after applying load, you have noticed that the length will increase. Clear? So this is that change in length is represented as delta. Now the strain will be equal to change in length over original length, and normal stress will be equal to P by A. Let A is the area of this bar. Clear? So this strain that is produced in the direction of force or along this direction, that is known as linear strain. And let if this is x, this direction is y, and this direction is z. So the strain that is given in x direction is epsilon x, and it will be equal to change in length divided by original length. So due to this tensile load, there will be elongation in horizontal axis. Clear? But at the same time, the height will decrease. There will be contraction in height as well as in width. Clear? So length increases positive की तरफ, but width and height that decreases, mean there is a contraction. So how you will find it? So you will find it by using Poisson ratio. Now what is Poisson ratio? Poisson ratio is actually represented as nu, and it is equal to lateral strain over longitudinal strain. Longitudinal strain. अब lateral strain क्या है? Means के this is the longitudinal strain, longitudinal direction, and this is other than longitudinal, that are lateral. This direction, this is lateral, and this is lateral. That is perpendicular to this longitudinal strain. So nu is equal to lateral strain over longitudinal strain, and it is written in these two brackets. What does it mean? It means that nu is a positive value. So how you will find it? So this nu will be equal to, so if the load condition is like this, only there is a horizontal force, so there will be strain in the x direction, and there will be a strain in y as well as in z direction. ये जरूरी नहीं है कि आपके पास सिर्फ लोड x डायरेक्शन में है, y और z में नहीं है, तो उस डायरेक्शन में स्ट्रेन नहीं होगा. नहीं, ड्यू टू दिस हॉरिजॉन्टल or normal load in x direction, strain will produce in x direction as well as in y and z direction, but there will that will be negative, means there will be contraction in x and y and z direction. Clear? So nu is equal to minus, what will be the lateral strain? इस डायरेक्शन में लेटरल स्ट्रेन क्या होगी? इट इज y, एप्सिलॉन y. सो माइनस एप्सिलॉन y ओवर लेटरल स्ट्रेन क्या है? एप्सिलॉन x. क्लियर? सिमिलरली अगर आप z के लिए फाइंड करना चाहते हैं, सो माइनस एप्सिलॉन, सॉरी ये y डायरेक्शन नहीं है, ये z है, z है, तो आई हैव टू चेंज इट z बिकॉज इट इज मेंशन ओवर हियर दैट दिस इज z डायरेक्शन. क्लियर? Now in y direction there is a contraction, so that is epsilon y over epsilon x. Clear? So if you want to find this, so that this will be equal to minus nu into epsilon x. Similarly, the strain in z direction will be equal to minus nu into epsilon x. So इस फोर्स लोड P की वजह से हमारे पास तीन किस्म के स्ट्रेन प्रोड्यूस हो गए. वन इज स्ट्रेन इन x डायरेक्शन, one is strain in y direction, and one is z. But one is positive, means that it is going to elongate in this direction, and the other two are negative, so it means there is a contraction in y and z direction. And how you can find the contraction? So you can use this formula, epsilon y is equal to minus nu time epsilon x. Similarly, epsilon z is equal to nu time epsilon x. Clear? So we'll move to upward again. So Poisson ratio, so this is the same thing which I have explained over here, यहाँ पे, ठीक है ना. So इसको भी देख लेते हैं. So this is the bar, ठीक है, subjected to load P, and this is x direction, the upward is y, and this is z. So now due to this force, you can see this was the original area, clear, and due to the load, applied load, the length is increased, clear. So this is the increase in length in x direction, but there will be a contraction, the diameter, the area is reduced, there will be a contraction in thickness as well as in weight, clear. So this is the scenario. If you simplify it, that load in x direction is given, there is no load in y direction, and z means no normal load in y and z direction. So in this scenario, there will be three strain, epsilon x, epsilon y, and epsilon z. So epsilon x can be found by using the stress strain equation. So that is epsilon x over epsilon y. Now epsilon, as the stress sigma y or load along y and z direction is equal to 0, so it does not mean that epsilon y will be equal to 0 and epsilon z will be equal to 0. No, the case is that due to this single load along x direction, I have discussed it here, that due to this load there will be contraction in x direction as well as in y direction, and that is the strain. So you have to, so according to that, sigma epsilon y is equal to epsilon z, that is not equal to 0. And how you will calculate that? For that we know the Poisson ratio. So Poisson ratio is lateral axis divided by axial strain. Lateral strain over axial strain. So lateral strain is along z direction is minus epsilon z, and normal axial strain is epsilon x, and lateral strain in y direction is minus epsilon y over normal or axial strain, that is this. So if you use that, so nu is equal to minus epsilon y over epsilon x. So you want to find epsilon y, so epsilon y will be equal to minus nu time epsilon x. Similarly, nu z is equal to minus nu time epsilon x. So you have find out the epsilon x, which is here, and epsilon y and epsilon z in term of Poisson ratio and axial strain. Clear? Any question?
No, sir.
Okay.
No, sir.
Okay. So also I will need another slide. So for example, up till now I have shown you that if you have the state of stress, for example, this is object, this is x direction, for example, is this direction is x, this is y, and this is z. मैं इसको भी थोड़ा रिमूव कर दूं. If this is, for example, if this direction is x, and you applied a load that is sigma x, clear? So in this condition, sigma x is there, but sigma y and sigma z is not equal, is not there. So they are zero. But due to this normal stress, strain will produce in x direction as well as in y direction as well as in z direction. And it will be minus nu into epsilon xx. And it is equal to minus nu into epsilon y. And this will be equal to sigma x over E. ये अभी तक हमने ये किया. So this is for unidirectional stress. This condition is known as unidirectional stress. But what if we apply the stress in y direction as well? Now this y is not equal to, sigma x is not equal to 0, and sigma y is not equal to 0, but sigma z will be equal to 0. So in that case, these strain will be produced. Also we will have epsilon y, epsilon x, and epsilon z due to this vertical strain, vertical loading, vertical stress, normal stress. Now what will be its value? Its value will be epsilon y, sigma y over E. And this epsilon x will be equal to minus nu time epsilon y. And this z will be equal to minus nu time epsilon y. समझ आई?
Yes, sir.
अच्छा, अब हमारे पास टोटल स्ट्रेन, अगर मैं इसकी कंडीशन लूं तो टोटल स्ट्रेन इन अलोंग एक्स डायरेक्शन क्या होगी? सिग्मा एक्स ओवर ई. ठीक है. और ये क्या है, इधर भी है ना, y फोर्स की वजह से, y लोड की वजह से, लोडिंग अलोंग y डायरेक्शन, सो दैट विल बी माइनस नू इनटू सलान y. क्लियर? सो ये टोटल डिफॉर्मेशन होगी इन x डायरेक्शन. Similarly for y direction, epsilon y will be there. So one y direction में जो x डायरेक्शन में जो लोडिंग थी, सिग्मा x की वजह से जो लोडिंग थी, उसकी वजह से y डायरेक्शन में कितनी स्ट्रेन आ रही थी? माइनस नू इंटू एप्सिलॉन x. अब y की वजह से y में भी पॉजिटिव आ रही है, दैट इज प्लस सिग्मा y ओवर e. क्लियर? एंड व्हाट इज टोटल, इसको मैं t लिख देता हूं, और ये भी t. और z डायरेक्शन में क्या होगी? तो z डायरेक्शन में होगा माइनस नू इंटू एप्सिलॉन y माइनस नू इंटू एप्सिलॉन, सॉरी ये मैं गलत लिख दिया था, इधर ये x है, नू इंटू एप्सिलॉन x. क्लियर? सो दिस विल बी योर टोटल strain. So these three are the strain that is produced due to the 1, 2 and 3. ठीक है ना? This is the total strain due to bi-directional loading. Bi-directional means normal stress in x direction as well as in y direction. Clear?
Yes, sir.
Okay. So now we will move toward three-dimensional when a bar or object is subjected to three-dimensional loading. So in that case we see what will happen. So ये डायरेक्शन में x हो गया, x डायरेक्शन में, ठीक है, सॉरी x, ये y डायरेक्शन में भी इस पे लोड आ रहा है, एंड z डायरेक्शन में भी आ रहा है. Now this is in three-dimensional loading. The body is under the action of three-dimensional loading. Three-dimensional stresses हैं. ठीक? Clear? मैं अगेन कह रहा हूं कि अगर आपको कहीं पे इशू आता है आप पूछें, क्योंकि अगर पूछेंगे तो चीजें क्लियर होंगी. अच्छा, अब हम आते हैं, पहले इसको सिंपल करते हैं. फॉर x मीन फॉर x डायरेक्शन. तो तो x डायरेक्शन में लोड क्या है, सिग्मा एक्स एक्स, तो इसकी वजह से कौन सा स्ट्रेन प्रोड्यूस होगा, सिग्मा एक्स एप्सिलॉन एक्स होगा। सिमिलरली y डायरेक्शन में कंट्रैक्शन होगी और z डायरेक्शन में भी कंट्रैक्शन होगी, और ये कंट्रैक्शन कितनी होगी, माइनस नू टाइम एप्सिलॉन एक्स, एंड दिस विल बी माइनस नू टाइम एप्सिलॉन एक्स, और ये इलांगेशन होगी जो कि सिग्मा एक्स ओवर ई के बराबर है। मैं किसी जगह अगर मैंने एक्स एक्स लिख दिया तो उसका मतलब सिग्मा एक्स ही है, ठीक है।
यस सर।
सो ये केस 1 के लिए जब सिर्फ और सिर्फ एक्स डायरेक्शन में लोडिंग हो। नाउ अब एक्स के साथ साथ वाई में भी है, तो वाई फॉर वाई डायरेक्शन, तो वाई डायरेक्शन में सबसे पहले तो वाई पे लोडिंग है, तो वाई में तो लेंथ इंक्रीज होगी लेकिन एक्स और जेड में कम होगी, तो एप्सिलॉन वाई क्या होगा, एप्सिलॉन वाई होगा सिग्मा वाई ओवर ई। अब एप्सिलॉन एक्स क्या होगा, उसमें कमी आ रही है एक्स में, तो दैट इज माइनस नू टाइम एप्सिलॉन वाई, एंड सिमिलरली जेड डायरेक्शन में भी माइनस नू टाइम एप्सिलॉन वाई। ये दूसरी कंडीशन। अब तीसरी कंडीशन ये है कि अब तीसरी z की वजह से जो z डायरेक्शन में जो ये मैंने इधर ये z है, सॉरी ये z है, कोई आप लोग भी सोए हुए हैं, आप लोग ये नहीं कहते कि ये z है, तो ये z है फॉर z डायरेक्शन। So if there is a tensile stress or tensile force in z direction, so definitely change in length occur, and there will be elongation in z direction. So that z will be equal to, ये भी z है, that z will be equal to sigma z over e. जबकि epsilon, there will be a contraction in x direction and that is minus nu into epsilon z, and similarly in y direction that is minus nu into epsilon z, ठीक है ना। तो जब अगर ये था पहली कंडीशन कि जब x फोर्स हो, ये थी दूसरी कंडीशन, ये थी तीसरी कंडीशन। अब जब बॉडी अंडर 3 डायमेंशनल लोडिंग है तो टोटल डिफॉर्मेशन कितनी होगी x डायरेक्शन में, x डायरेक्शन में टोटल डिफॉर्मेशन कितनी होगी, तो इस x को लें, इस x को लें, सॉरी स्ट्रेन इन x डायरेक्शन और इस x को, सो इट विल बी इक्वल टू सिग्मा x ओवर e माइनस नू टाइम एप्सिलॉन y, ये वाली, और फिर माइनस नू टाइम एप्सिलॉन z, क्लियर। फिर टोटल स्ट्रेन इन y डायरेक्शन वो कितनी होगी, अच्छा अब y में देखते जाएं, एक y ये है सिग्मा y ओवर e, दूसरा y क्या है, ये है विच इज माइनस नू इंटू एप्सिलॉन x, एंड तीसरा y ये है माइनस नू इंटू एप्सिलॉन z, एंड सिमिलरली टोटल स्ट्रेन इन z डायरेक्शन वो क्या है, अब z डायरेक्शन में ये है सिग्मा z ओवर e माइनस ये क्या है माइनस नू इंटू एप्सिलॉन, अगर x तरतीब में लिख लें तो बेहतर है, माइनस नू इंटू एप्सिलॉन x एंड माइनस नू इंटू एप्सिलॉन y. Now this is the total strain in x direction due to 3-dimensional loading. This is the total strain in y direction due to 3-dimensional loading, and this is strain in z direction due to 3-dimensional loading. Clear? Any question?
यस सर, क्लियर।
अच्छा, तो ये यही चीज यहीं पे एक्सप्लेन है, ये देखें ये जो इधर ये है, ठीक। सो अगर आपके पास लोड है x डायरेक्शन में भी, y डायरेक्शन में भी और z डायरेक्शन में भी, तो टोटल स्ट्रेन जो होगा वो इसके बराबर होगा जो कि मैंने इधर डिराइव किया हुआ है। ये अगर आप दोनों अपने पास लिख लें और दोनों को मैच करें, दे विल बी द सेम, ठीक है। तो फिर अगर आप जब ये स्लाइड्स देखें तो आपको पता होना चाहिए कि ये लिखा हुआ है और ये कहां से आया है, ठीक है ना। सो टोटल स्ट्रेन इन x डायरेक्शन इज दिस, टोटल स्ट्रेन इन y डायरेक्शन इज दिस, एंड टोटल स्ट्रेन इन z डायरेक्शन इज दिस। वन मोर थिंग, दैट पॉइजन रेशियो का हमने कहा था लेटरल स्ट्रेन डिवाइड बाय एक्सियल स्ट्रेन, ठीक है ना, और इसके साथ हमने इधर मॉड भी लगाया था। इसकी वैल्यू पॉजिटिव आनी चाहिए। बट जब हम कहते हैं इधर यहाँ पे कि जब हम ये फाइंड करते हैं, ये Poisson ratio is equal to minus epsilon y over epsilon x. Why we have taken this y? Because we know that in y direction there is a contraction, so ये value negative होगी, so negative will give you a positive value, and that's why epsilon, the value of epsilon is a positive value. You will see next in next few slides as well. Clear? यहाँ तक clear?
Yes, sir.
Okay. Now we will see that let we have a cube. Let we have a cube and having each dimension as unit. In x, in y direction it is unit, and in z direction is in it's in unit. When this is applied to three-dimensional loading as shown over here, sigma x, sigma y and sigma z, so definitely there will be change in length in x direction, in y direction as well as in z direction. Clear? So let this change will be 1 plus, in x direction it is 1 plus epsilon x, in y direction it is 1 plus epsilon y, and in z direction, in this direction, it is 1 plus epsilon z. So where value of epsilon x, epsilon y and epsilon z is given over here. ठीक है ना? अच्छा, तो फिर क्या होता है, हम इसको इसलिए एक्सप्लेन कर रहे हैं कि वी आर मूविंग टुवर्ड अ न्यू टॉपिक, दैट इज डायलेटेशन और बल्क मॉडुलस. नाउ व्हाट इज डायलेटेशन और बल्क मॉडुलस? अप टिल नाउ we talk about strain, that is change in length over original length, that give you linear strain. This is known as linear strain. So what about if volume change? So change in volume per unit volume or original volume, change in volume per unit volume, that will give you dilatation. Dilatation. It is the ratio of dilatation is basically the ratio of change in volume to the original volume. So again, if this is the cube having unit dimension in each, and after applying three-dimensional loading, now there is an increase in length in every direction, in x direction, in y direction as well as in z direction. Clear? So initially the volume is what? 1 multiplied by 1 multiplied by 1. So it will be 1. So initial volume is 1. Now new volume is what? New volume. Volume new. वो किस चीज के बराबर होगा? 1 प्लस एप्सिलॉन x, इसको मल्टीप्लाई करें इस लेंथ को, इस लेंथ को और इस लेंथ को, मल्टीप्लाई बाय 1 माइनस 1 प्लस एप्सिलॉन y मल्टीप्लाई बाय 1 प्लस एप्सिलॉन z. जब इन तीनों को मल्टीप्लाई करेंगे न्यू वॉल्यूम आएगा. आएगा?
यस सर.
अच्छा, फिर आपने क्या करना है, फिर आपने इन सब को मल्टीप्लाई करना है, तो आपके पास कुछ इस तरह इक्वेशन आएगी. मैं पूरी की पूरी इक्वेशन नहीं लिखता, लेकिन मैं यहाँ पे नीचे थोड़ा लिखता हूँ. वी न्यू इज इक्वल टू 1 को 1 से मल्टीप्लाई किया 1 आया, 1 को एप्सिलॉन y से मल्टीप्लाई किया तो एप्सिलॉन y आया. सिमिलरली एप्सिलॉन को इससे मल्टीप्लाई किया तो एप्सिलॉन x आया, और इसको इससे मल्टीप्लाई किया तो ये एप्सिलॉन x इंटू एप्सिलॉन y आया, एंड सो ऑन. जब ये कंप्लीट हो जाए फिर इनमें इनके जो टर्म्स हैं उसको आपने मल्टीप्लाई करना है इससे, एंड सो ऑन. अब कहने का मकसद ये है कि एप्सिलॉन काफी छोटी वैल्यू है, ठीक है ना. तो अगर 2 छोटी वैल्यू या 3 छोटी वैल्यू लेट्स से 0.1 है, तो ये 0.1 के 0.2 के साथ मल्टीप्लाई हो जाए तो क्या आता है 0.02, विच इज अप्रोक्सीमेटली इक्वल टू 0. So we will neglect these terms. So आखिर में हमारे पास v new जो निकल आएगा, that will be, जो आखिर में आप जब ये सॉल्व करेंगे, so आपके पास आ जाएगा एप्सिलॉन x प्लस एप्सिलॉन y प्लस एप्सिलॉन z. तो ये v new आ जाएगा. Now what will be change in volume? Now change in volume is equal to original volume minus new volume. Original क्या था 1 और new क्या है -1 into minus 1 प्लस एप्सिलॉन x प्लस एप्सिलॉन y प्लस एप्सिलॉन z, ठीक है ना। तो ये 1 1 के साथ कट जाएगा और हमारे पास चेंज इन लेंथ जो होगा वो ये आ जाएगा, ठीक है। यहाँ पे मेरे ख्याल से थोड़ी सी मुझसे कोई मिस्टेक हुई है, ये सारी की सारी जो है वो चेंज इन लेंथ इज एक्चुअली कम्स आउट टू बी एप्सिलॉन x एप्सिलॉन y प्लस एप्सिलॉन z, ठीक है ना। अच्छा, हम कहते हैं, सॉरी मैंने गलती क्या की है, चेंज इन वॉल्यूम इज इक्वल टू न्यू वॉल्यूम माइनस इनिशियल वॉल्यूम। अगर आप इसको उल्टा कर दें तो ये हो जाएगा न्यू और ये ओरिजिनल हो जाएगा, तो -1 इधर आ जाएगा। तो आपके पास चेंज इन वॉल्यूम जो होगा वो होगा एप्सिलॉन x प्लस एप्सिलॉन y प्लस एप्सिलॉन z. So this is change in length. Now, so we have defined dilatation as the ratio of what? Change in volume per unit original volume. Clear? So change in volume क्या है? एप्सिलॉन x प्लस एप्सिलॉन y प्लस एप्सिलॉन z. ओरिजिनल वॉल्यूम क्या था? y 1 था, ठीक है ना। So this is known as dilatation, ठीक है ना। अब बल्क मॉडुलस क्या है? बल्क मॉडुलस जिस तरह आपने यंग मॉडुलस पढ़ा था इसी तरह बल्क मॉडुलस भी है। बल्क मॉडुलस इज एक्चुअली the material property and it is resistance to the volumetric deformation. Bulk deformation आपको शो करता है resistance to the volumetric deformation. Clear?
Yes, sir.
So dilatation comes out to be epsilon x epsilon y plus epsilon z. अच्छा, ये हो गया यहां तक, ठीक है ना। Now अगर मैं अगेन मैं इसका डुप्लीकेट क्रिएट करता हूं और मैं आपको एक चीज शो करना चाहता हूं, इसमें है कि नहीं, लेट मी चेक 1 मिनट। ओके, नहीं है। ओके, दैट इज नॉट मेंशन। सो उसे भी मैंने आपको दिखाना चाहिए। 1 मिनट, डुप्लीकेट स्लाइड, लेट्स सी द सेम थिंग इज, आ गया डुप्लीकेट स्लाइड। अच्छा, ये यहाँ पे भी आ गया, यही चीज है। सो अगर मैं इसको यहाँ से रिमूव करूं, ये जो मैंने लिखा है, लेट मी डिलीट ऑल दीज थिंग्स। ओहो, सो नाउ ये जितना भी केस अभी तक हमने डिस्कस किया था, ये सारा का सारा जिसमें ये 3 डायमेंशनल स्ट्रेसेस थी, दे आर इन टेंसाइल स्ट्रेसेस, ठीक है ना। दे मे बी कंप्रेसिव स्ट्रेसेस एज वेल. So let's talk about that. अच्छा, इसको इससे मिटा देते हैं. So up till now we discussed the volumetric change and original volume, and we discussed what is dilatation, that is the ratio of change in volume divided by original volume, and then we discussed the bulk modulus, that is resistance to a volumetric change. Now you have seen that this problem is solved by using the stresses that are normal, but these are tensile stresses. What if all the stresses in y direction, in z direction, x direction, as well as z direction will be in compressive? ये भी हो सकता है case. So in this condition, the object is said to be in hydrostatic pressure because the pressure exerted from every edge is same. So this, in this case, sigma x is equal to sigma y is equal to sigma z is equal to p. Clear? Minus p, because they are compressive. So अगर आप इस इक्वेशन में, अच्छा ये इक्वेशन अब यहां तक तो हमने कर दिया था, डायलिटेशन ई से रिप्रेजेंट होता है, और हमने कहा था आखिर में कि डायलिटेशन बराबर है एप्सिलॉन एक्स एप्सिलॉन वाई प्लस एप्सिलॉन जी. नाउ in this condition we can say that further अगर आपके पास ये जो इक्वेशन है E is equal to एप्सिलॉन x प्लस एप्सिलॉन y प्लस एप्सिलॉन z, इसमें आप एप्सिलॉन x की जगह ये वैल्यू पुट करें, ये वाली वैल्यू कहाँ गई जो हमने फाइंड की थी यहाँ पे, ये वैल्यू पुट करें इस एप्सिलॉन x की जगह टोटल, इस एप्सिलॉन y की जगह ये पुट करें और इस g की जगह ये पुट करें इस इक्वेशन में, ये जो अभी मैंने आपको दिखाई है इस इक्वेशन में, और इसको सॉल्व करें. दैट इज अवेलेबल इन बुक. ठीक है, अगर कोई इसको सॉल्व करना चाहता है, देखना चाहता है, दैट इज अवेलेबल इन बुक. सो जो आखिर में इक्वेशन आपके पास डायलिटेशन की आती है वो आती है 1 माइनस 2 नू ओवर ई इंटू एप्सिलॉन एक्स प्लस एप्सिलॉन वाई प्लस एप्सिलॉन जी. ठीक है, यहां तक क्लियर?
Yes, sir.
Acha, now if the stresses are compressive one, if all the stresses are compressive one, this sigma y, sigma x and sigma z, they are compressive. So that will be in state of hydrostatic pressure, and let this, all the stresses are same, so that will be minus P, internal pressure P. ठीक है ना? So replace, I will put the value of, मैं इधर वैल्यू पुट करता हूं. सो E विल बी इक्वल टू 1 माइनस 2 टाइम्स नू ओवर E इनटू सिग्मा x की जगह माइनस P, सिग्मा y की जगह माइनस P और सिग्मा z की जगह माइनस P. सो ये हो जाएगा माइनस 3P. सो E विल बिकम इक्वल टू माइनस 3P इंटू 1 माइनस 2 नू ओवर E, जो कि यहां पे देखें ये लिखा हुआ है. क्लियर?
Yes, sir.
अच्छा, नाउ इफ आई लीव P ओवर हेयर, ठीक है ना, अगर मैं इस E की, ये इसको मैं मिटाता हूं दरमियान में से, एक मिनट, तभी अभी क्लियर हो जाएगा स्टेप वाइज. अच्छा, इफ आई लीव दिस P ओवर हेयर, क्लियर, माइनस P, एंड दिस E इज देयर, जब अगर मैं इसको डिवाइड करूं दोनों ऊपर और नीचे, तो दैट विल बी 1 माइनस 2 नू इंटू 3 हो जाएगा ना,
Yes, sir.
जो कि यहाँ पे दिया हुआ है. ठीक है ना, यहाँ पे. अब इस टर्म को ये दिस E ओवर 3 इंटू 1 माइनस 2 नू, दिस इज अ कांस्टेंट एंड इट इज रिप्रेजेंटेड एज K, and this constant is known as bulk modulus. जिस तरह E था हमारे पास यंग मॉडुलस था, तो K जो है वो बल्क मॉडुलस है. और बल्क मॉडुलस किस लिए फाइंड करते हैं? वॉल्यूमेट्रिक रेजिस्टेंस टू, इट शोज यू द रेजिस्टेंस टू वॉल्यूमेट्रिक चेंज. ठीक है ना, और इस K की वैल्यू है E ओवर 3 इंटू 1 माइनस 2 नू. So this equation will become E is equal to minus P, and instead of writing this whole term we can just write K, where K is bulk modulus. So dilatation will become equal to E is equal to minus P by K. Clear?
Yes, sir.
अच्छा, the last thing is that K, आप देखें तो इसमें इस टर्म में जो K is equal to E ओवर 3 इंटू 1 माइनस नू, इसमें ये E की वैल्यू पॉजिटिव है और K की वैल्यू भी पॉजिटिव आती है. ठीक है ना, सो ये टर्म पूरा का पूरा पॉजिटिव होना चाहिए. सो फॉर दैट वी, इफ E इज पॉजिटिव एंड K इज आल्सो पॉजिटिव, सो डेफिनेटली 1 माइनस 2 नू शुड बी ग्रेटर देन 0, क्योंकि ये टर्म अगर ग्रेटर देन 0 होगा तो ये K की वैल्यू पॉजिटिव आएगी ना.
Yes, sir.
So 1 minus 2 nu should be greater than 0, or implies that 1 is greater, or 2 nu is less than 1. ठीक है ना, and nu is less than 1 by 2, means कि nu की वैल्यू जो है वो 0.5 से नीचे कम होनी चाहिए. means Nu ranges greater than 0 and less than 0.5. So nu जो है Poisson ratio उसकी वैल्यू हमेशा greater than 0 होती है, less than 0.5, and nu is a positive value. That's why अगर आपको याद हो तो यहाँ पे मैंने आपको कहा है कि हम nu के साथ यहाँ पे mod लेते हैं. क्यों? क्योंकि nu की वैल्यू पॉजिटिव है. और फिर मैंने आपको ये भी बताया था कि यहाँ पे हमने nu इज इक्वल टू माइनस लिखा हुआ है. तो माइनस इसलिए लिखा हुआ है क्योंकि वाई डायरेक्शन में भी कंट्रैक्शन हो रही है, सो ये वैल्यू भी माइनस होगी. सो माइनस माइनस द वैल्यू ऑफ nu विल बी प्लस. क्लियर?
Yes, sir.
अच्छा, एंड आई थिंक यस, शेयरिंग स्ट्रेन. अब जिस तरह just like normal stress produces normal strain, in the same way this shearing stress. Now what is shearing stress? When the stress applied over a surface is parallel to the area on which it is acting, so that type of stress is known as shear stress. Now due to shear stress, shear strain produced, and shear strain is represented as gamma. Clear? So you can see that this is a cube and the shear stress is applied top of xy, top of yx, and the angle between these two edges is 90 or pi. Clear? Initially it is pi. Now due to shear stress, shear strain will be produced. And what is shear strain? Shear strain is actually deformation, the angular deformation between the two surfaces. ठीक है ना? So this, after applying the shear stresses, it will slide like this. Clear? अगर आप देखें इधर आपको नजर आ रहा हो तो, let me zoom. So you can see now the angle is now reduced, but here the angle is increased. Similarly, यहाँ पे angle increase हो रहा है और यहाँ पे decrease हो रहा है. So initially it was pi by 2, now it is pi by 2 minus gamma into xy. Shear stress, shear strain. Similarly, it is here it is increasing. So this gamma into xy is shear strain in that plane, and this is measured in radian. So जिस तरह आपको याद हो, stress is equal to E into epsilon x. अगर x डायरेक्शन में, अगर y में है तो ये y हो जाएगा. So this is Hooke law for linear stress or linear strain के लिए. So here shear stress is represented as tau into g into gamma. Now tau is, you can see this is stress, but this is normal stress. This is stress, this is shear stress. This is strain, that is linear strain, and this is strain but shear strain. This is E, which is modulus of elasticity, but here this G is known as modulus of rigidity. So it basically, this is for linear system and this is for rotational system or tend to rotate. ठीक है ना? So it is analogous of force analogous of rotational system. So हमारे पास जो है वो shear stress बराबर है G into gamma simply. ठीक है ना? Clear?
Yes, sir.
अच्छा, अगर आप मुझे एक 2 या 4 मिनट और 5 मिनट और देते हैं तो let me clear one important concept and then we will quit the lecture. ठीक है ना? So अगर बोर हैं तो we can take 4-5 minute
No,
break.
sir.
Let take 3 or 4 minute break. I will also drink water. Let's start with that. For example, if you have a body like that, सुन रहे हैं आप मुझे?
Yes, sir. Yes, sir.
इसको थोड़ी तवज्जो दें, ये आपके लिए फायदेमंद साबित होगी. आपको कहीं पे भी मसला आएगा तो आपको क्लियर होगा. Let's say this is direction x, this is direction y, and this is direction z. Clear? सो आपको ये पता होना चाहिए कि एक्स वाई डायरेक्शन में जो प्लेन आता है, एक्स वाई डायरेक्शन में जो प्लेन आता है, ठीक है ना, वो जेड प्लेन आता है। ठीक है, ये एक्स है, ये एक्स है, सॉरी ये एक्स, ये जो फ्रंट को अगर आप देखें तो ये वाई डायरेक्शन है और ये जेड है, सॉरी वाई डायरेक्शन है एंड दिस इज एक्स। सो दिस फ्रंटल, दिस प्लेन इज नोन एज जेड प्लेन। सिमिलरली वाई जेड जो प्लेन है दैट विल बी एक्स प्लेन। अब वाई जेड प्लेन, वाई जेड क्या है, वाई इज दिस डायरेक्शन एंड जेड इज दिस डायरेक्शन। सो ये वाला जो प्लेन है, ये वाला that is known as x plane. Clear? And similarly zx. So zx क्या है, z ये है, ये डायरेक्शन है और x ये है। so ये वाला जो प्लेन है, ये टॉप वाला, ये होगा y प्लेन। इस तक समझ आ गई आपको?
यस सर।
अच्छा, अब हम आते हैं स्ट्रेस मैट्रिक्स की तरफ। आपने ये नाम शायद पहली दफा सुना हो या हो सकता है सुना भी हो। सो हम स्ट्रेस प्लेन, हमारे पास फॉर 3 डायमेंशनल प्लेन हम इस तरह रिप्रेजेंट करते हैं, सिग्मा एक्स एक्स टॉ ऑफ एक्स वाई। मैं समझाता हूँ आपको इसके बारे में, टॉ ऑफ एक्स जेड। सिमिलरली सिग्मा वाई वाई, सॉरी गलती हो गई, टॉ ऑफ वाई एक्स, sigma yy and tau of yz. Similarly, tau of zx, tau of zy and sigma zz. This is known as stress matrix for three-dimensional stress. ठीक है ना? Clear? And as well as all the shear stresses are also available it. So now we will simplify it. सबसे पहले तो आप ये देखें कि लेट से यही आपके पास बॉडी है और आपके पास सिर्फ x डायरेक्शन में स्ट्रेस है, ठीक है ना? तो आपके पास स्ट्रेस मैट्रिक्स इसका क्या, किस तरह बनेगा? इस बॉडी पे कौन कौन सी स्ट्रेसेस लग रही हैं? जी, सिग्मा एक्स लग रही हैं। तो ये सिग्मा एक्स होगा, ये सारी की सारी वैल्यूज जो हैं वो 0 होंगी, ठीक है ना? सिमिलरली अगर आपके पास इस तरह ये वाई डायरेक्शन में है तो ये आपके पास ये स्ट्रेस मैट्रिक्स जो हो जाएगा वो ये हो जाएगा, सिग्मा एक्स एक्स 0 0 0, सिग्मा वाई वाई 0 0 0 0। तो फॉर दिस स्टेट ऑफ स्ट्रेस, ये वाली your stress matrix will be like that. But if there is stress in z direction as well, so now this will not be 0. So this will be equal to what? Sigma z z. ठीक है ना? अब आते हैं इनके बारे में देखते हैं। So इसको किस तरह टैकल करेंगे? अगेन इसको इस तरह टैकल करेंगे या इसको इस तरह समझेंगे कि मैं फिर से दोबारा ये बनाऊंगा। अच्छा, जब आपके पास इफ यू हैव द सेम अगेन सेम ब्लॉक, सॉरी, दिस इज x डायरेक्शन, दिस इज y एंड दिस इज z। नाउ सबसे पहले बिफोर डिस्कसिंग दैट वी विल सी, हमने लिखा हुआ है टॉ ऑफ एक्स वाई, टॉ ऑफ एक्स जेड। इसी तरह हमने लिखा है टॉ ऑफ वाई एक्स, टॉ ऑफ वाई जेड, या टॉ ऑफ जेड एक्स और टॉ ऑफ जेड वाई। ये है क्या चीज, इसको हम रिप्रेजेंट किस तरह करेंगे? सो इसमें इन जो नीचे ये जो वैल्यूज हैं एक्स वाई है, इनमें एक्स का क्या मतलब और वाई का क्या मतलब? या ये पहले वाला जो है 1 और ये है 2, तो 1 का क्या मतलब है? ये सबस्क्रिप्ट है कि मैन्युस्क्रिप्ट है? क्या कहते हैं जो सबस्क्रिप्ट होता है, क्या कहते हैं जो छोटा? हाँ,
यस सर।
मतलब आपको समझ आ गई कि मैं कहना क्या चाह रहा हूँ? अच्छा, मैं आपको इधर थोड़ा जूम करके आपको समझाता हूँ। टॉ ऑफ एक्स वाई, दिस इज फर्स्ट वैल्यू एंड दिस इज सेकेंड वैल्यू। नाउ दिस फर्स्ट वैल्यू शोज यू plane. क्या चीज?
plane.
Plane. And the second one show you direction. Now how we will plot it and you will be able to understand that. Tau of xy. So x plane. By x plane means x plane means yz direction. So this is y and this is z. So this plane is x plane. So this shear stress will be in this x plane. Clear? But in the direction of y. So this direction can be upward or downward, depend upon the situation. So this stress is known as this is represented as tau of x y. Clear? अब हम आते हैं tau of xz. Now what does tau of xz mean? X plane, but in the direction of z. So ये x plane है और ये direction of z जो है वो इस direction में है. Z is. So that is tau of xz. Similarly, tau of yx. So y plane कौन सा होगा? ये वाला. ये x और z डायरेक्शन में जो है ये प्लेन जो फ्रंटल है ये वाला. एक मिनट मैं आपको ये मार्कर से हाईलाइट करता हूं.
टॉप वाला नहीं होगा?
नहीं, ये क्या है? ये x, हाँ सॉरी, टॉप वाला होगा. एग्जैक्टली, गुड. x डायरेक्शन में ठीक है ना? और नहीं, टॉ ऑफ वाई एक्स. तो वाई प्लेन की बात करें तो वाई जी, हाँ ये टॉप वाला. सो ये टॉप वाला जो होगा ये होगा वाई प्लेन. क्लियर? अब हम टॉ ऑफ वाई जेड को वाई एक्स को रिप्रेजेंट करते हैं. टॉ ये वाई प्लेन है और इन द डायरेक्शन ऑफ एक्स. सो ये देखें टॉ ऑफ वाई एक्स. अब एक सिचुएशन यहां पे भी देखें. टॉ ऑफ एक्स वाई ऊपर है, टॉ ऑफ वाई एक्स अपोजिट है. ये दोनों एक दूसरे के साथ मिल रहे हैं. और हम आप शायद बुक में भी अगर किसी टाइम मिला सो हम कर लेंगे. अदरवाइज ये बुक में एक छोटा सा टॉपिक है विच शो दैट टॉ ऑफ एक्स वाई इज इक्वल टू टॉ ऑफ वाई एक्स. सॉरी, वाई एक्स. सिमिलरली टॉ ऑफ जेड एक्स इज इक्वल टू टॉ ऑफ एक्स जेड. ठीक है ना? तो ये अलग एक टॉपिक है, उसमें हम ये प्रूव है कि ये बराबर है. अब हम आते हैं, ये भी हो गया, ये भी हो गया, ये भी हो गया. अब टॉ ऑफ वाई जेड. तो वाई प्लेन यही है और जेड डायरेक्शन कौन सी है? ये वाली है. सो ये क्या होगा? टॉ ऑफ वाई जेड. क्लियर? अच्छा, टॉ ऑफ जेड एक्स. अब जेड प्लेन कौन सा है? ये वाला, ये वाला. ठीक है ना? टॉ ऑफ जेड इन द डायरेक्शन ऑफ एक्स. तो एक्स की डायरेक्शन कौन सी है? ये है. ये क्या है? टॉ ऑफ जेड एक्स. अब टॉ ऑफ एक्स जेड इस डायरेक्शन में है, टॉ ऑफ एक्स जेड इस डायरेक्शन में है और टॉ ऑफ जेड एक्स इस डायरेक्शन में. दोनों आपस में मिल रहे हैं ना? सिमिलरली टॉ ऑफ जेड वाई. तो ये जेड प्लेन है और वाई डायरेक्शन में ऊपर ये वाला टॉ ऑफ जेड वाई. तो ये देखें टॉ ऑफ जेड वाई और टॉ ऑफ वाई जेड आपस में मिल रहे हैं. तो आप अगर आपको सिंपल में, अब कहने का मकसद मेरा ये है कि अगर आपको एक बॉडी दी गई हो, इस तरह एक बॉडी दी गई हो और उस पे आपको स्ट्रेसेस दी गई हो, एक्स डायरेक्शन में हो या शेयर भी दी गई हो और एक्स वाई और जी डायरेक्शन भी डिफाइन हो और आपको कहा जाए कि आप उसका स्ट्रेस मैट्रिक्स लिखो, तो आप लिख सकते हो?
यस सर.
तो जो स्ट्रेसेस होंगी, नॉर्मल स्ट्रेसेस होंगी, वो आप डालें. जो नहीं है तो वो जीरो हो जाएंगी. और जो शेयर स्ट्रेसेस हैं वो आप डालें और जो नहीं है वो जीरो हो जाएंगी. सिमिलरली आपके पास स्ट्रेन मैट्रिक्स भी है और वो भी इसी तरह है. एप्सिलॉन एक्स एक्स, गेमा ऑफ एक्स वाई, गेमा ऑफ एक्स जी, गेमा ऑफ वाई एक्स, एप्सिलॉन वाई वाई, गेमा ऑफ वाई जी, गेमा ऑफ जी एक्स, गेमा ऑफ जी वाई एंड एप्सिलॉन जी जी. ठीक है ना? तो इंशाल्लाह किसी दिन टाइम मिला तो हम इसको और भी डिटेल से देखेंगे। बट जो मैंने आपको जो सिखाना था बेसिक, जो बताना था, अगर मोस्टली आप लोगों को पता होगा बहुत को, लेकिन अगर किसी को नहीं समझ तो उनकी रिवीजन हो गई कि अगर आप मैं कहूं कि टॉ ऑफ एक्स जेड को प्लॉट करो तो आप यू मस्ट बी एबल टू नो और यू मस्ट बी एबल टू प्लॉट टॉ ऑफ वाई एक्स जेड, टॉ ऑफ जेड एक्स, टॉ ऑफ वाई जेड एंड सो ऑन। क्लियर? अच्छा, अब जो मैंने इधर देखें लिखा हुआ है सिग्मा एक्स एक्स, तो इसका क्या मतलब? एक्स प्लेन है और इन द डायरेक्शन ऑफ एक्स। सिग्मा वाई 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 प्लेन है इन द डायरेक्शन ऑफ वाई। और सिग्मा जी जी लिखा, अगर जी जी लिखा है तो इसका मतलब ये जेड प्लेन है और इन द डायरेक्शन ऑफ जेड। क्लियर? So this was all about second lecture, or you can say the part B of second lecture. If you have any question, you can ask. Thank you.